Carbon capture will play a central role in advancing sustainable management and the reduction of greenhouse gas emissions. Besides its natural qualities as a CO2 absorbent material, Moroccan clay presents itself as an attractive resource within the scope of this project, as it is inexpensive, highly accessible, and environmentally friendly. By capitalizing on the properties of Moroccan clay, the prototype aims to capture CO2 in order to enhance plant growth and counter air pollution. The two most important carbon sinks on the planet are the oceans and vegetation. Carbon naturally moves in and out of these sinks by everyday processes. However, due to human activity, such as deforestation and desertification, CO2 is being released at a much faster rate. In response, I have explored the possible technical and systemic implications of extracting CO2 from the atmosphere, asking the question, could Moroccan clay be used to develop an autonomous facade system that captures and stores carbon dioxide from the atmosphere? The facade system utilizes local materials to ensure that a sustainable prototype allows for an on-site study of selective parameters that engages socially, artistically, and scientifically with the urban context of Marrakesh. Atmospheric air is drawn into the capture panel where carbon dioxide binds to clay minerals on the surface of the tile. Once the temperature rises, carbon dioxide is released and the water release mechanism is activated. This initiates the washers to unload the CO2 from the tiles. CO2 and water forms carbonic acid that drips down into the collector panel, where tomato plants absorb the CO2 through the leaves and roots and use it to grow. The CO2 absorbent performance of the clay was tested with a separate test unit to have better control over the trigger parameters. However, the test results showed that the smectite clay used within the prototype was capable of absorbing CO2 from the ambient air. Data loggers were used to document the performance of the panel system for 2 weeks. It was recorded that the average day temperature was 2 to 8 degrees Celsius higher inside the panels compared to outside. The tomato plants which were exposed to higher CO2 concentration had significantly more vegetable growth compared to the control plants. It seems like recently there are more and more examples of performative facades and materials serving both as structure and as a notification about ecological concerns. In addition to testing the apparatus technically, the prototype uses imagery to visually disrupt. As an object in public space, the prototype also acted as a social catalyst, drawing people's attention and sparking conversation.